We spend so much time and energy securing our data. We lock it down when it's stored on a drive, we protect it when it's flying across the internet, but what about its most vulnerable moment? We're going to dive into a critical security gap that exists when your data is actually in use, and explore how a whole new approach is locking it down for the age of AI.
This right here, this is the core promise of what we're talking about today. I mean, just imagine running your most valuable AI model or processing super sensitive customer data with the absolute certainty that nothing, not even the cloud provider, not a hacker, nobody, can peek inside while it's happening. That is what runtime protection is all about, and honestly, it's a complete game changer. So think about it this way. We've gotten really good at encrypting data when it's just sitting there on a hard drive. That's what we call data at rest. And we use stuff like HTTPs to protect it as it moves across the network. That's data in transit. But here's the catch. The exact moment an application needs to actually use that data, it has to be decrypted. And for that split second, it's totally exposed in memory. That's the in-use security gap, and it's where some of the biggest risks are hiding.
Yeah, this really is data's final frontier. For way too long, that in-use phase has been the Achilles heel of our entire security strategy. As soon as data is decrypted in memory, it's fair game for malware, rogue administrators, or even the underlying cloud system itself. This is the exact vulnerability that confidential AI was designed to slam shut.
So what's the fix? Well, the solution is actually pretty brilliant. It's all about creating a tiny, ultra-secure vault, but not in a bank somewhere. This vault is built directly inside the computer's processor. It's like a hardware-enforced safe room where only your authorized code can get in, and absolutely nothing on the outside can see what's going on inside.
Now, this secure vault we're talking about, it has a technical name. It's called a Trusted Execution Environment, or TEE for short. This is the foundational technology that makes the whole idea of confidential AI possible. It's what creates that hardware-level isolation we were just talking about.
And the key here, the thing you've got to remember, is that a TEE isn't just some clever piece of software. It is a hardware-based feature. It literally carves out an isolated space in the silicon where both your code and your data are protected. And this is so crucial. Not even the machine's own operating system or the cloud provider's hypervisor can look inside. The trust is rooted directly in the chip itself.
Okay, so let's put it all together to make it super clear. Traditional security, right? It protects the bookends of the data journey when it's in storage and when it's in transit. Confidential computing comes in and completes that security trifecta by zeroing in on that critical middle phase, the processing. It means your data is now protected from end to end at every single stage of its life cycle.
So how does this secure vault, or enclave as it's technically called, how does it actually work under the hood? We're going to take a peek at the key components, but don't worry, we won't get lost in the technical weeds, because understanding the how really shows you why this is all so powerful.
It really boils down to three main pieces. First, you've got the enclave itself. That's the secure vault. Second, the data inside that vault stays encrypted even while it's in the computer's active memory or RAM. And third, and this might just be the most important part, is a process called attestation.
This brings up a huge question, right? How can you possibly trust that the vault you're about to send your secrets to is the real deal, and not some clever fake set up to steal your data? Well, that's exactly the job of attestation. Think of it like a cryptographic handshake that gives you digital proof, a certificate of authenticity, if you will, that the environment is genuine and hasn't been tampered with. It lets you verify before you trust.
The whole process is actually pretty slick. First, your application asks the processor for a secure enclave. In response, the processor creates one and hands back this cryptographically signed report. That's your digital proof of security. Your application checks that proof, and only when it's completely satisfied does it release the keys to unlock and process the sensitive data inside that now trusted environment. It's a beautiful, secure little dance.
And hey, this isn't just some theory or a lab experiment. This is available right now. The major cloud providers, we're talking AWS, Google Cloud, and Azure, they all offer virtual machines with this capability. They're built on these powerful hardware technologies from the big chip makers, mainly Intel's SGX and AMD's SEV, which each have a slightly different way of creating these secure enclaves. Okay, so we've covered the what and the how. Now let's get to the most important question of all, the so what. How does this technology actually create value in the real world, especially for all of us building and using AI?
Well, the applications are pretty incredible. Think about protecting a company's secret sauce AI model, their crown jewels, from being stolen even while it's running on a third-party cloud. Or, and this is even more powerful, imagine a bunch of hospitals training a shared cancer detection model on all their patient data, but without ever having to expose that sensitive information to each other. This enables a level of privacy-preserving teamwork that was basically impossible before.
It's also really important to see this as one powerful tool in a much bigger toolbox, what we call a defense-in-depth strategy. It is not a silver bullet. But when you combine the hardware isolation of a TEE with other privacy-enhancing techniques, like differential privacy, which cleverly adds statistical noise to data to protect individual identities, you end up creating an incredibly strong fortress for your most sensitive information.
So let's wrap this up. Confidential AI is, without a doubt, a transformative technology. But like any powerful tool, it's not without its trade-offs. And to make smart decisions about using it, you really have to understand both sides of the coin. So the upside is huge and pretty clear. You get this unprecedented security for your data while it's being processed, protecting you from even the most privileged attackers like the cloud admins themselves. The trade-offs, though, are practical. All that constant encryption and decryption can slow things down a bit, creating some performance overhead. And it's not as simple as flipping a switch. Your developers need to work with specialized hardware and software, which definitely adds a layer of complexity to a project.
You know, this really signals a fundamental shift in how we have to think about security. The old model was all about building a static fortress, a big wall around your data. The new model, powered by confidential computing, is about putting your data inside a secure, moving vault that protects it no matter where it goes or what it's doing. It is an incredibly powerful new capability. The only question left is, what will you protect inside your vault?